So, hi everyone. Welcome to Aim High, the Nature First Curiosity powered online school. Can you all hear and see me okay? I think you can. Cool. My name is Dr. Jazz. I am the resident astrophysicist slash radio astronomy space person at Aim High. And today we're going to be doing something a little bit far out that you've probably all spoken to friends and family about before, whether or not there are aliens out there, whether there is life out there, and whether or not they are intelligent. So the first thing I want you to answer me is, if an alien appeared in your room right now and you were capable of communicating with it, what would you ask an alien? So for those just joining, I'm Dr. Jazz, this is Aim High, and I just want you to tell me what question you would ask an alien if it appeared in front of you. Da-da-da. I'm from the planet Enceladus. It's not a planet, it's a moon. Where are you from? Sorry, I'm just joking around. How did you get here? That's a really good one. So talking about the technology. Can you help us with our greenhouse gas problem? That's awesome. That is why I put this silly picture up on the screen. How did you get here? Okay, any others? I would probably ask personally, well, what would... Did you come down the chimney? That's good. I think I would ask them if they listened to music or if they were capable of like love, what their society was like. So many different questions I'd want to know about them in terms of their behavior and nature. So the next thing I want you to think about is, I want you to imagine you're an alien now and that you were teleported to the Earth in one of these four places. So we've got 1, the rainforest, 2, the Mariana Trench, 3, the salt plains. So they're really salty. They're old evaporated seas. The lakes that form on them are so alkali that they burn your skin. And then 4, your living room. Oh, and for those of you that don't know, the Mariana Trench is the deepest point in the ocean, so it's pitch black and there's loads of water on top of you. It's really loads of pressure and stuff. So imagine you're teleported to one of these 4 places. How would you be able to tell that there's life there? Does anyone know? What would you think if you landed in the rainforest? How would you be able to tell that there's life? Yeah, listen, I like to think that there would be so many sounds. We've got birds and forest animals. What about, you'd just feel the moisture. There'd be so much noise, and you would be just surrounded by life, just greenery and things like that. So what about in the Mariana Trench? What evidence of life do you think would be there? Tracks. So in the water or on the salt plains there might be tracks. So in the Mariana Trench, we can think of, I don't know if you've seen Finding Nemo actually, with all of the colour. So with the little light that appears and it's attached to that big old angler fish. This is something that fish that live really deep underneath the water, or creatures that live underneath the water, they have this thing called bioluminescence. So if you were in the bottom of the Mariana Trench, you might see loads of lights floating around, and that would be just life trying to attract mates and attract prey. So even on the salt plains, animals like flamingos have adapted to have really, really coarse, rough skin that doesn't dissolve or get damaged in those alkali lakes. They can even drink the water there because they have filters in their beaks that get rid of all of the salt. So what about in your living room? What evidence of life would there be in your living room? Any guesses? So in your plants, yeah, you might have plants in your living room, magazines, human things, TV, lights, sofa, crumbs, food. This is great. Okay. Yeah, so you might see evidence of technology, so bear that in mind for later on. And you might see evidence of just plant life and things. So even in volcanic underwater oceans where the temperature is hundreds and hundreds of degrees, creatures like these tube worms can happily exist. So on the Earth, we have a huge diversity of very inhospitable different environments that are all capable of sustaining life. So what if you were transported to the moon and you were looking back at the Earth? What indications, what hints would you get that the Earth might have life on it? There's a bit of delay on my chat, so I'll wait. Yeah, lots of green again, we're saying. Lots of green, yeah. So it's blue, you might see clouds and oceans and things. Sorry, I've lost my mouse. Can you see the ring? This is really good. We've got Puddle of Ape saying, can you see the ring of light glinting off satellites from the moon? That's awesome. Well, artificial lights and city lights. Okay, so I want you to think of lots of green on being one side, and then all of the artificial lights and stuff glinting off satellites on being on the other side. Yeah. So if it was night, you could see the lights. If it's day, you'd be able to see water and lots of green. Okay, so now what if we were at Pluto? Well, this picture was taken by the Voyager spacecraft just as it left the solar system, which is about at the same orbit of Pluto. Now, I don't know if you can make this out, but this tiny little dot here is the Earth, and it's called the pale blue dot. And from that distance, the Earth is just a pale blue dot. So you'd need something much more powerful to be able to see the Earth from there. And you might just be able to think, well, it's blue, maybe there's water on it. So it starts to get more complicated to figure out if there's life from a distance. Now, what if we're at Alpha Centauri, our nearest star? Okay, well, that's 4.5 light years away. You're not going to be able to see the Earth against the bright sun that we have, unless you have a really good telescope. So this picture is an artist's impression of the Kepler Space Telescope, which was a space telescope that's just finished its mission and detected over 4,000 planets around other stars in our galaxy, which is what we call exoplanets. So this is a way that we can see other planets around other stars. So I want us to think of this talk as being looking for life. So remember, we saw all of those, we were talking about looking for greenery and water, versus listening for aliens. So that's listening out for all of our technical signals, okay? So the first thing we're going to talk about now is this word biosignatures. And I want you to look at this picture and try and guess what the word biosignatures means, or tell me what this picture is. Da-da. Does anyone have any idea what a biosignature might be? Montreal, evidence of life. Yeah, so I want you to, okay, yeah, that's a really good point about the squares being houses and farms and things. So that's quite artificial. But I want you to just look at what's happening in the water there. Sign of life, yeah, okay. So what's happening in the ocean is that these algae blooms, this is algae forming. So if we were looking from the moon at the Earth at this point, we'd see over a period of time a little green patch appearing. And that would be a physical change in colour of the surface of the planet that probably can only be due to life. Well, what's more interesting is that these algae blooms are giving off oxygen. So they're actually changing what our atmosphere is made of over a short period of time. And this is what we can think of a biosignature as being. It's the change in the planet's ecosystems caused by life. So what about these creatures? What biosignatures are they giving off? Yeah, methane, straight away. Exactly. Cool. Methane, yeah, gases. So the main one is methane. That's what we've got here. Cool. So these guys are giving off methane. And if we were looking at the atmosphere from outside, we'd probably be able to see that methane. And we might be able to be clever about it and think, is that methane coming from life, or is it coming from something like geology, like rocks, or maybe a volcano? Well, life exists for quite a long time. So that methane is going to be at a level in our atmosphere floating around where it's not too poisonous for life to exist, but it's not disappearing. It's staying constant because the amount of life on that planet is staying constant. Whereas if we had a volcano or something, we'd expect a huge, massive amount of methane that's toxic to life, that's going to knock everything else out of the atmosphere. But it's going to disappear really quick because just a volcanic explosion won't last as long as life existing on that planet. Cool. So I'm going to show you a picture now, and I want you to guess what it's a picture of. Bonus points if you know where it was taken. Sun and the Earth. Yep, exactly in there. From the moon? No, not from the moon. It was taken by Colonel Hadfield on the International Space Station. And it's the sunrise appearing over the Earth. So this thin blue line, we call it a thin blue line, is the Earth's atmosphere. Look how thin it is compared to the size of the planet. But then inside that atmosphere contains all of the ingredients needed to sustain life. This is the air that we breathe. So I'm going to show you something now, and it's going to get a little bit scientific, so don't worry. I just want you to have a think about what this might be telling us, this plot here. It's got some labels on it of different molecules. Some of them you might know, some of them you might not. So, pretty sure we all know that one. Global warming. Nope, it's not. It can tell us more about global warming, but it's not an image of global warming. What it's an image of is what our atmosphere is made of. So I'm just going to have a little look what else have people said. We've got light. Sort of. It's sort of light. Yeah, I think light is a really good way to think about it. So all it is are gases in our atmosphere. So this is a picture of the Earth from out of space, and it tells us exactly what the atmosphere is made of. Oh, we've got Nigel with them saying absorption of the atmosphere. So yeah, that's exactly it. When the lines go down, it means light's getting sucked in by that molecule. When the lines go up, it means that that molecule's spitting out light that we can see from outer space. Here we go. This is me looking at the Earth from outer space. So different combinations of these, so different amounts of oxygen and different amounts of water can, in our atmosphere, act as a blueprint for life. So when we start looking at planets around other stars, we can think of them as our own Earth and try and see if some of these molecules that exist in the atmosphere exist around other planets. So Kepler, that space mission we just talked about, did something clever. It knew that when, if a star dips in light for a certain amount of time, then a planet's probably passed in front of it. And if it figured out that that planet had passed by in front, a load of scientists on the Earth and Kepler itself would go back and have another look to see if a planet had existed there. And remember, Kepler did this with over 4,000, so it was quite a successful method. But we need a much more powerful telescope to basically get that thin blue line that's around that planet, and when the light from the star that it passes in front goes through that atmosphere, we want to be able to break it up into all of those gases that exist that we just saw, similar to the Earth. This process is exactly the same as a light going through a prism. That white light, so all of our normal light coming in, going through that prism, splits it up into a rainbow of colours. And when we look at atmospheres around other planets using this method, it's really similar to just breaking up the light to tell us what that light is made of, so we can figure out what was in that atmosphere. So there's a joke in the astronomy community that this telescope will never get launched, but it's supposed to be launched this year or next year. It's called the James Webb Space Telescope, and it's going to try and look at some of these atmospheres around other planets. Now, it won't be powerful enough to tell us whether or not there's life on that planet, but what it will be able to tell us is if that planet is capable of supporting life. So now for the kind of cool alien bit. I want you to tell me what these creatures are doing that makes them intelligent. I'll wait for a bit. It's cute, yeah. Yay! Picasso. Everyone loves Picasso. Yeah, cool. So we've got the crow is using tools. We've got orca's social behavior. Yep, awesome. So I'm going to put here, I think for the crow, I'm going to do problem solving. So what's it doing? It's got to get the right sized cork and the right weight cork to drop it into the water to get the food up. Crows are so intelligent actually that they can plan ahead. They are capable of solving problems in a similar way that we would do in chess, where we think moves ahead. Then we've got Picasso, which everybody loves. Picasso is painting here using different colours. So I'm going to put creativity. And then we've got advanced social behavior, someone said, which is awesome, cooperation. And communication is key between these creatures. Orcas are my favourite animal, by the way. And I'm actually terrified of them and have nightmares of them coming out of the water and just eating me. Yeah. So cool, intelligent orcas, yay. So we've seen what intelligence is. We can see that crows are intelligent, orcas are intelligent, but if we were in outer space and we were looking at the Earth, there's no way we'd be able to see an orca. There's no way we'd be able to know that a crow was using corks to get food out of a bottle. So how do we know that there's intelligent life in space? So we've seen biosignatures. I want you to try and guess what a technosignature might be. Oh. Yeah, my solar flares emanating from my head. I've got a big sun behind me. Yeah. Okay, cool. Yay. We have the big buzzword here, which is radio waves, someone said. You guys know a lot. This is really great. Lights, yep. So lights. Remember when we said about the moon and Pluto? Be really hard to see lights from a distance, but radio waves. So this picture is a picture of Seoul in South Korea. I'm going to spell it wrong. That's terrible. And at the back here, we've got these big masts on this mountain, and they are probably mobile network masts. They're going to be emitting these things called radio waves. Now, the thing that's different about radio waves and light is that radio waves can keep going in space for a really, really long time, whereas light kind of gets warped and disappears in our atmosphere. So, radio waves have been around for a very long time on Earth. We've been emitting radio waves since the 1900s. So the first broadcast, not radio signal that was made, but the first broadcast was made in 1906 by a guy called Reginald Fenison. And what he did was he broadcasted a choir singing at Christmas Eve to the, I always forget the name, the United Fruit. Oh no, it's a really good name. I've forgotten what it's called. The United Fruit Company, who were sailing around in the Caribbean and the Atlantic Ocean at the time, and it was a Christmas miracle, all of the angels singing, but they weren't in the same room as them. So these signals have been being transmitted from Earth for 115 years. So that means that around the Earth we have a radius, a big old circle of radio signals going 115 light years. So we've been emitting stuff out into space so far that it could be reaching stars and planets that are 115 light years away. Remember, our nearest star is only 4.5 light years away. So I want you to think about all of the TV and communications and stuff you send every day, and think about if you were an alien species and you were suddenly getting all these signals, how would you figure out the behavior of the human race? What would you think the human race is like? So just while you think about that, I've got a question saying, do they stay strong even as they radiate outwards? They fade quite a lot, not too much, but quite a bit. And the signals we're sending out are actually quite weak. So ideally, I didn't want to go into this too much, but they'd need to have a really big detector to be able to hear it. So we'll talk about that a little bit later on. Cool, we've got, it'd be like the film The Day the Earth Stood Still. Planet covered by United Fruit, yes. Yeah, that's great. So I get worried that there would be, they'd think we still live in the Middle Ages, that we kill everyone, and that I don't know, it would just be a mess. I feel like every TV show that's on Netflix has some complicated murder situation in it. I don't want to be giving that message to aliens. So actually, we're getting more and more advanced as time goes on. Oh, whoops, I've lost my thing. We're getting more advanced as time goes on. So someone said satellites earlier. Yeah. So we're actually getting noisier and noisier. And what's more likely is they're not going to get a broadcast that's like a nice, clear, crisp television show. They're going to just be hearing loads of digital noise. Out in space, there are so many satellites now that it's getting to a point where launchers are getting concerned about hitting debris that's out there in space. That is a topic for another day. I'll talk about space junk and things like that another time. The main thing I want us to think about is just the fact that out in space we have weather satellites, we've got GPS satellites, mobile satellites, imaging, military, you name it, communications, all sorts of things out there around the Earth that are all quite noisy, sending weird digital type signals. Okay, so this is actually kind of a problem for radio astronomers on the ground. But radio astronomers are pretty clever, and they write really good computer programs that can take away all of that noise from outer space and leave it with the nice space signals, astronomy signals. Whoops. So I don't know if anyone's seen this before. Okay, so we've got, is that a pic of satellites around the Earth? It's a model. It's not a photograph. We don't have a photograph of it. It's a model of how many there are. So the satellites have been made a bit bigger so you can see them in the picture. But you can see how many that there are. Okay, so I want you to have a look at this picture now. And I want you to say if you've ever seen anything like this or what you think that these are. Okay, so we've got the 1 kilometre square of satellite. No, this isn't... I'm not sure if that was what I think it was. Anyway, these are radio telescopes. They look like satellite dishes, and they do something very clever. Unlike the Kepler space mission, it's easier to do radio astronomy from the ground because we can build loads and loads of telescopes, and the further apart they are, the bigger the telescope kind of becomes and the further into space we can see. So light from our alien civilization hits this telescope, then a few seconds later it hits this telescope, and that little angle that it makes there tells us where it is, how far away it is. And then our computers can do clever programming algorithms that can figure out whether that signal looks like something we might have seen in astronomy before. Maybe a star with a magnetic field that's just exploded, so something like that. Or maybe it's some weird technological signal that kind of looks like our own satellites. So we can use our own noise to tell us maybe that's what a communicating signal looks like. We've got a little robot emoji with bloop written next to it. Yep. So is it a big old bang in space, or is it a little robo bloop? I'm going to write bloop next to it. I like that. Cool. So the group that write a lot of these algorithms to look for aliens and do all the computer modelling to figure that out are a group called the SETI Institute, and SETI stands for Search for Extraterrestrial Intelligence, and this picture is of their observatory in Northern California. Cool. So I want us to move on now to just a little bit of maths. So fun maths time. Thought you could escape maths, but you can't. I want us to do some little maths problems. I'm gonna roll 1 dice. I'm going to roll this dice here. And I want to roll a 4. What is the probability of me rolling a 4 with 1 dice? Does anyone know? Yay, cool. We've got 1 in 6, so we've got 1/6. Awesome. Good going. I'm going to ask a harder one now. I'm going to roll both of me dice, and I want to get a 3. So I've got 2 dice, and I want to roll a 3. Does anyone know what the probability of that would be? Yeah, so lots of people saying 1/6. Awesome. What about this second situation though? Rolling a 3. No, it's not still 1 in 6. So I've got my first dice. So I'm going to call this one dice number 1 and this one dice number 2. And I want to roll I want the sum. Oh, I'm sorry. I should have phrased that better. I want the sum of the dice to be 3. How embarrassing. I got the question wrong. How are you supposed to get the answer right if I get the question wrong? We've got 1 in 36. Okay, so getting there. Cool. Okay, so if I want the sum to be 3, then on the first dice, I could roll a 1, and then on the second dice, I would have to roll a 2. Or my only other option is that I would have to roll a 2 on my first dice, and then I'd have to roll a 1 on my second dice. Okay, so that adds to 3. Now, the total number of options we've got here is we've got 6 on 1 times 6. So we've got 36 different possibilities. And we can only get 2. That means that the total number is 3. So that's 2 out of 36 or 1 out of 18. So that would be our probability of rolling yeah, cool. So I think we're all good. I've shimmy my screen along. Cool. Okay, awesome. So just a little bit of probability there. Right, cool. Everyone happy with the dice rolling thing? 2 out of 36. I think we're all, 1 out of 18. We're all getting it. That's great. Cool. So when it comes to the probability of life, we end up getting a really complicated game of cosmic dice happening. And this can be sort of thought of as being a thought experiment. And this thought experiment, known as the Drake equation, was put across by a scientist at the SETI Institute called Frank Drake. And what this probability thing does is it makes us think about how likely intelligent life is of contacting us. So the first thing we kind of need to know is how fast do stars form. We need to know that because we need to know how many stars there are. We need to know how old those stars are, and whether or not those stars have been around long enough for planets to form. So then the next thing is, how many of those stars have planets? Then we need to know the number of planets that can support life. So we're getting less and less likely as we go down. Then we need to think about how many of those will go on to develop life. Because if it's a really early planet, like the early Earth, then it might not have supported life yet. Or it just might not have had the right ingredients to be able to do that. Then we think about how many of those actually develop intelligence. So are there alien crows on the planet that are solving problems to get their snacks? And at what point are those alien crows going to be able to start sending signals to us? And then the last thing we need to think about is how long have those signals been being sent out in the first place? Because we saw Alpha Centauri, that's 4.5 light years away. Well, if last week some aliens on Alpha Centauri suddenly did their United Fruit Company emission, sending out that radio signal. We're not going to get that for 4.5 years. So right now we could be like, it's very unlikely that there's life, but in 4 years' time, maybe we would find that signal. So it's exploring the possibility of there being life out there. So I want to go back to that little looking for life versus listening for aliens. Looking being trying to find signatures of space slime, algae on other planets, maybe there's liquid water. That's looking for signs of life. That was our biosignatures. And I've got a picture of the James Webb Space Telescope there. Now, it's very likely that there's going to be space slime, because we've seen how there's loads of different life on Earth that can live in really harsh conditions. So that's pretty likely. But what's unlikely is us being able to build something that's sensitive enough to be able to detect it. Ooh, I'll write that here. So it's easy to, but no, let's phrase this better. It's likely, but it's going to be hard to find. Whereas listening for aliens with our big radio telescopes, we know that that's pretty reliable. It's very easy to do. We can do it on the Earth. We can do it with the more telescopes we have, the better chance we have of doing it. But what's the chance of there being intelligent life out there? This was very unlikely, as we saw, because there's so many different dice we have to roll to be able to form that intelligent life. So I want to ask you, which of these do you think we'll figure out first? Do you think we'll find a planet that we can say, yeah, there's definitely life on there because we've seen all this greenery with our space telescopes? Or do you think it's more likely we'd hear a weird technical signature and we'd be like, oh, somewhere out there, there's some weird digital signature coming? What do you think? Which do you think we would be able to detect first? Bio, we've got someone saying. Bio, yeah. So rather hear it. Techno, someone says. Mears91 says techno. Here, yeah, okay. So me personally, I think I get more excited by the idea of there being things like space whales out there, like big, huge ocean worlds with giant whale creatures, really highly developed social things going on. That really excites me. But I think we probably detect technological signals first. So the last thing I want to say is, do you think that there are aliens out there looking for us? What do you think? Do you think we're more likely to be detected before we detect them? Oh, cool. We've got SETI's been looking for a long time. More logical to look for biosignatures. Yeah, well, hopefully the James Webb Space Telescope will shed some light on that, literally. And we might be able to find some planets worth pointing at. Oh, wow. Okay. Some things about what alien species might be wanting to do to the human race. Okay, cool. Right. How do we know that we haven't been detected? Well, we don't. So this is why we keep looking. And that picture at the bottom is from it's Jodie Foster and Carl Sagan's Contact. If you want to know a little bit more about what life is like looking for aliens, this is a bit more glamorous than in real life, but it's worth just looking at that film. Okay, cool. I think I'm going to finish up there. Thank you so much, everyone, for listening. And I'm just going to say a little bit about Aim High. So Aim High are doing loads of these learning adventures. We've got an exciting one coming up next week talking about the gender pay gap, and then we've got one talking about what goes into developing vaccines and how they work and things like that. So if you enjoyed what we did here, this was quite technical. So some of our lessons are aimed at kind of younger audiences as well. So please follow us on social media, sign up for our newsletter. And also soon we've got a climate course coming up. So the reason I wanted to talk so much about Wales and the diversity, I chose Wales again, and the diversity of life on Earth and what you would ask an alien is because what's the point of looking for aliens if we can't sustain our own planet and look after it and all the insanely cool diverse life that is out there. So we've got one question. Have you ever heard something looking like aliens from space? Yeah, actually quite a few times. Loads of radio astronomy, I'm just going to answer this question. Loads of radio astronomy discoveries were originally thought to be alien signals, but then what happens is that they team up with observational people and they look at where it was in space, and then there's people that do computer models of stuff, and they usually narrow it down to being some weird phenomenon like a star exploding, because the power is just too great for it to be maybe something artificial, or maybe it's just behaving in a way that we've seen in nature. Remember that space is nature as well. These things that happen in space, like stars exploding, black holes colliding, dust going around galaxies, accelerating particles and things, it's still nature. And astronomy is a natural science as well. So there's signals that we get that we like to think of it being a kind of natural signal, but sometimes it takes a few years of computer modeling and lots of follow-up observations to try and find out whether or not that's actually happened. Cool. Okay, there's some cool stuff happening in the chat, but time is up, I'm afraid. So yeah, thank you everyone. Do give Aim High a listen, and just check out all of our other lessons and look at our climate course as well that's coming up soon. So thanks so much everyone. Bye bye.